Hello everyone. Uh, let's wait a few more minutes and we'll start soon. I'll just check once again the material. Okay. Yeah, it mustn't be bad. Okay, good. Um, I think we can start. So this is chapter 3 of our C# bootcamp, and we'll start learning all about C#, all about the nice things that the language offers. No more fundamentals. Now we'll get to move on more interesting language specific features and somewhat advanced topics. And so the chapter itself is probably the longest one. It will have 15 lessons in total. So today is lesson 1, and this is the order of lessons. It will match more or less. So we'll start from the syntactical sugar, that is a list, enum, properties, and indexers. And the next lesson we'll talk about out, ref, and in keywords. Then we'll talk about generics, about struct, about multidimensional inject arrays, delegates, lambda expressions, extension methods. We'll talk about LINQ, how to write basic LINQ filtering and more, how to use query syntax of LINQ, how to use and create custom attributes, how to work with different formats of file, most common ones like JSON and XML, how to use NuGet packages to ease our work and not do everything by ourselves, how to do operators overloading, how to use, create tuples, and how to deconstruct tuples and other types into specific fields. And lastly, we'll talk about other useful features of C#, of .NET that we didn't mention, but that are maybe not commonly used, but is really important to be aware of. So let's get to the agenda of today's lesson. Today specifically we'll talk about what is a generic type, what is a list, what is a benefit, an advantage of list over array, and what is a property, how do we define property in different ways, and indexer, and what is a enum, and how does it compare to constant. So this lesson basically will make your code way cleaner. And by saying way cleaner, I mean you'll be writing basically 30% less code for the same job, or maybe even more. So it's a really good lesson and hope you like it. So let's start from a list. So just think, what if we could add or remove elements to an array without doing anything by ourselves? What if we could remove an element at any index or by any value? What if we had whole sorts of utility operations, such as to check if array has any elements, to clear the array of all elements, and so on and so forth. And in fact, there is an answer to this problem, and that answer is called a list. So an example of list can be seen here. Here you can see we have created a list of numbers, and by writing this very similar to array, for array it would be, instead of list of int, it would be int array. So we have new list of int with 1, 2, 3 as elements in that list. And if I call add and say 4, I add an element at the end of the list. If I say remove 4, that means I remove element by value in the list, so the last one. If I say remove add and I give it 3, then it will remove the third element by index. If I call clear, it makes the list empty, and if I call any, it checks if list contains any elements. And in this case, it doesn't contain any elements, and therefore it's false. So what is a list? Remove removes by value. There is a very similar method called remove at. And if I call remove at 3, it will remove at third element. Otherwise, I get, out of range exception. All right. So list is a data structure designed for the same purpose as array, for storing many things of the same type. It's a class, essentially. It's a class, a generic class. So what a generic class is, it means that it doesn't care what type it interacts with. It will be able to treat whatever type you pass to it in a generic way, but consistently so. So for example, if I create a list of int, that means all elements in that list and all the things that I add or remove or check for existence, they will all be integers. That's the generic type. So list is a class of generic type T, and when we create a list, we specify that generic type that the list is. So when we create a list, in this case, we said that it's a list of integers. So between less and equal sign, we specify what kind of a list is it. So a list is a whole bunch of utility methods for working with collections of elements that we want to add or remove, just to store many. And that's the way to go if you don't know the size of your collection. If you don't know if it's 1 or 2 elements, you should be using a list. And so this is creating a new list, this is adding an element to a new list, and this is removing element, in this case the first one from that list. Aurora asked, what happens if you eliminate an element that is not at the given index that you want to remove at, for example, 4, when we have only one element? And the answer is it will throw array out of bounds exception, because it's an array in the end, and under the hood it's still an array. It's just a nice encapsulation. So yes, it's very similar to array. So here you can see an example that if you use numbers remove 4, I think, it will not throw, but we can try this out later. I'm not sure, but I think it will not throw. Because a list can have multiple values of the same thing, and it's not probably a big deal if value does not exist in a list. So if you remove something that doesn't exist, maybe it's not a big deal. But we'll see about that. I'll mark this in my notes to play around with this during live coding. So here in this example, you can see 3 different lists. So in a list of words, I can only add strings. In a list of numbers, I can only add ints. And in the list of bools, I can only add bools. And the point here is that it's the same class, but applied for different types, specified for different types. And that's the benefit of generic. You can have a generic class which works with no type in particular, because all different types can be treated in a generic way. Like, I don't need to know if a type is a string or an int or a bool if I just want to add or remove elements in that string. However, if I'm removing something from some collection, I really need to know what type it is when I'm working internally, and therefore we use generics because the type needs to be specific and consistent. So if I created a list of t, I need to be working with the same t consistently. Because, for example, if I compare int to string, that simply won't compare. So it needs to be consistent across a certain type of a generic. So if I use a new list of string, that means I can only add strings to it. And so there is an interesting thing about a list, and that thing is size doesn't matter. So, however, if you create a list, you can add or remove elements. You can give it an initial size. So if I create a list, I can say it's a list with capacity of 5. But that doesn't mean that this list is with a size that does not change. That just means that it has some optimization, which basically presumes that a list will most likely not exceed 5 elements, so it makes sense for it to have initial capacity of 5, so that it doesn't resize itself, that it doesn't have more allocations than needed. This, however, is micro-tuning, micro-optimization, and I don't remember the last time I cared about this. But it's just a nice thing to know that this doesn't matter. This doesn't mean that the list cannot have more than 5 or less than 5 elements. That just means that it will have some optimizations, that it will have size which is more optimal for 5 or less elements. And that's it about list. I'll answer that last question for sure when we go back to Visual Studio. So now let's continue and talk about property. What is a property? And the major misconception that most people have is that they don't get it, that properties are not data. Properties are functions, they're methods. They are methods for getting or setting data, or in other words, a value of a field. So when we had our getter and setter methods that we implemented manually, that's what properties are essentially. They are getter and setter methods. And they can be either just a getter, just a setter, or both. they cannot be neither, because then it will be just a field. And in C#, that's how we define our properties. We do not say set something, get something. We always use properties for manipulating a single field when it's trivial. However, a property itself, even though it can have logic, in most cases it should be as simple as it can. Because you don't expect setting a name to throw an exception, or you don't expect getting a share name to, let's say, save an entry in database. You don't expect those kind of things. And properties should be kept simple. And if you look at the property name, its access modifier is public, and thus get and set access modifiers are also public. They come from the first access modifier that property uses for declaration. And you can have your own custom properties if you want. That is fine. That would just mean, just like a method opening a scope. Properties are just syntactic sugar. They basically allow you to have quick encapsulation. So basically hiding the data and exposing it through setter and getter methods. That's properties for C#. And from the outside, it will look just like a field. You won't call it as a method. There's no brackets needed to call it. You just call it as if it was a field. But that's also the convenient part of it, because getters always have no input and setters always take the same type of value. So you don't really need to pass anything in those methods, in those setter and getter methods. And therefore, you can have a template on how getting and setting values is done. There is a problem though. People think that having properties is good enough encapsulation, but in fact, having properties is just a fake encapsulation, because you don't really abstract away the details of a class good enough if you make everything public properties. You should still have consideration of what data you really want to expose through those methods and what you should really keep private. So there's still that consideration that remains before you make a final choice of either keeping it a private field or exposing it through a property. And here is how you implement custom getter and setter methods. I think the key point here is that you see when you set when you have a setter property, you have a special keyword in the body of a setter. You see you have set name underscore name equals value, and set underscore name equals value means string. So you pass in a string to a name. So you set value of name to the value that came to the setter after the equality sign. And when you return it, you can return whatever you want, some backing field. But anyways, when you implement custom getters and setters, there always has to be that backing field. And I see a tiny mistake here. It should have been underscore surname and not name. Doesn't matter that much. And one more thing. So here we have a public string name and no access modifier setter, only property. So this means that setter is public, but we explicitly said that getter is private. So this means that we have a set only property. This means that we can set from outside, but we can only get from inside. And this part is probably not needed because getting a value of a name is the same as just getting name field. So we don't really need this get part. So this is actually bad design, and this part could be removed. And we can have a get only property like this one, where you see I just returned a concatenated name and surname as full name. So I just say new person, and then I say person.full name, and it will return those two concatenated nicely. And so there are 3 ways how you can implement a property in C#. You can have a custom property, so a backing field and getter setter methods for setting and getting that backing field values. An auto property with get set methods, that's all it takes. Oh, sorry, the first one is an expression bodied method. So custom property with expression bodied method. What does this mean? This means that I have this arrow here, and this arrow allows me not to write scope. And if it's a one-liner, I can use this arrow. So this is called expression bodied property. As long as this is one-liner, it will work. So you can see I can save some code by using this kind of syntax. Second one, auto properties, and third one is just full custom get only property. So custom properties, expression bodied properties, and a auto property. So use properties for exposing data. Sorry, where? Oh, you mean for name, getting name. Yes, it's a typo. It should be underscore name. Yes. So why properties are not fields? Because properties are more readable. So first, properties are not fields because properties are some encapsulation. Why properties are not methods, not setter getter methods? Because they add readability and they take slightly less time. And Cat Girl asked, do we need a return keyword? We don't need a return keyword. That's also another benefit, right? We can just say that and it understands it, that it's implicitly a return. But it only works for one-liner methods. And in C# we have a special kind of property which is called indexer. Every class can have a single indexer. So consider this. We have an inventory class with a list of items. And all we care to see how many of those items do we have. And we have different types of items: potions, weapons, and armor. And so we can have an indexer for getting a count of each type of item. So we would have under the hood some count items method, and our getter would just count the items. So this thing here says that we have keyword this, and this means that inventory can be accessed through those brackets. Again, I should have shown a slightly better example with using it. So inventory can be accessed through those brackets. I'll do this in live coding, don't worry. And if I pass to inventory a string, like potion, weapon, or armor, it will return the count of items that I have in here. And this is called an indexer. I can set and get something by accessing a class through this special key kind of filter. And you cannot have more than one indexer because the syntax would not allow it, because it is being called through this keyword. I will experiment with this after in live coding. I might be saying this slightly wrong, that there can be overloaded indexers like methods, but we'll see. We'll see. I will explain about this. Actually, I should explain now, because I agree that it's not clear. So here we have an indexer, like inventory, and let's give an example. So I created an inventory. That's something that you already know. And then I say potions count. So I say inventory, and then I can access inventory like this, because there is an indexer like this. So you see those broken brackets where you pass a string type. And here I have those broken brackets where it asks me to pass a string type. So I say item types, weapon, for example, potion. And it will literally just go through and return potions count. Is this clear? What it does? And what this will call this method. Because I passed the string to count the items. And yeah, you can overload the indexer, of course. That is fine. So I should fix this. I don't know why I wrote I will delete this. This is not true. I don't know why I wrote that. And there was another question which we can cover as well now, since we moved slightly off track, which was what happens if you remove an element at a given index? So we can quickly remove it. So we have this list. And let's say we remove an element. I'll move this all to its own function so that it's not in the way. And let's have items. And let's remove item 0. So yeah, it did not throw. That did not throw. So those two answered. Let's go back to slides. So what is the property? Yeah. So that is indexer that we just that I just showed. So it's a special kind of property that you can set and get. And consider this just like a method overload. Again, a method, a special kind of methods. Yes, it did nothing for non-existing value. Or in other words, it removed all the zeros from the list. There were no zeros in the list, so it did nothing, basically. Now let's move on to one last topic, which is Enum. Enum is just a collection of tags, you could say. So you have a predefined collection of tags. So it's a type, and it's very similar to a constant. So if I have a gender Enum, male, female, or other, that means those are my genders. I know what kind of values the genders can have. I don't need to do any validation because that's my Enum. So gender, male, will return me an Enum with value male. And this is a very lightweight value, basically an int kind of value. And Enum has indexing starting from 0. So if I don't have any indexing in here, that means that male converted to int would be 0. Female would be 1 and other would be 2. And I can convert those to an integer by casting. So indexing of Enum can be overridden. If I say female equals 6, then that means that female casted to int will be 6. And everything that goes after it will be incremented, so other will be 7. If I convert Enum to string, it will be the value of that Enum, not an integer, but what is written. So male to string will be male string. No, it won't be null. In this case, it will not convert, I think. You won't be able to cast 1 to gender. It will throw an exception. Again, we can try that in coding before too many questions stacked. So we have Enum versus constant. When should you use which? And here's an example for traffic lights. So you have an infinite loop which basically switches traffic lights. You start from red, and then it goes yellow, green, red, yellow, green, red, yellow, green, and it prints that to a console. Quite trivial. However, this code is not quite efficient, and it could be simplified because we have a default case which says unrecognized, because we need to know to have it just in case. So there is that part. So we still are working with strings and not something strongly typed. So that is the benefit of Enum. It's strongly typed and does not need validation compared to a string. And And yeah, that's pretty much it. It's strongly typed. That's why we should use enum versus constant. That's a good reason enough. So again, give some time to yourself to look at this example and look what happens when we switch to Enum implementation. There is quite some code that just dropped because we no longer need to switch the value, because Enum itself tells what value it is, and all we need to do now is to convert the Enum to an integer and add an extra index to it, and then convert the integer back to Enum. So yes, this is quite more simple. And this is all I wanted to show. Now, whoops. Now let's do that example. So I have the genders, and I have 0, 6, and 7 for genders. What happens if I cast the gender to let's move this to another example. So what Enum will 1 be? So if I do this, it did not throw. Okay. And it tried to cast and it failed to cast, and it kept itself a number, but it's a gender. And I cannot explain why it acts this way, honestly, but it's definitely something to be aware of. Especially since if you do this, you know, it still works. And gender is not an int. That's the point. Gender is an enum. It's male, female, or other. But if you try to cast it, even though it's invalid, it will not fail. So there's this little quirk that you should be aware of. Yes, it's a gender. It will change to female if I set it to 6. So let's say plus equal 5. You see, it went to female. From 1 to female. So it's a bit bizarre, weird, but also interesting. I don't really like this. I would prefer it would throw, but fine by me, I guess. So now please try to write one thing that you think you understood very well, and one thing that you would like to know better about this lesson, about properties, enums, or a indexer or list. Yeah. So try to write one thing down, one sentence that you think you understood very well and that you would like to understand better. And I'll be right back, 1 minute. Um, all right, I'm back. So from top, understood everything, but I don't see how the counter works. Roll-off, I don't understand how the counter works either. But I wouldn't bother myself with this. It's nothing important. It's more like of a geeky, interesting stuff, low-level stuff to. Um, I am unable to explain enums at bigger level at exactly why this is the behavior, but I could investigate and present the results the following day. This is definitely interesting. Next, about indexer. So Mihail, what's unclear about indexer? Uh, what exactly are you confused about? And so I'll move on to Hunter Max. I'd like to know more about getting and setting. If we write public string name get set, what does it do under the hood? How does it look like? So I already showed how getter and setter looks like. Well, it's the same in the code. So getting and setting under the hood looks like this. So it's literally the same as this. So under the hood, this will generate a backing field with get and set methods, which set the value of that backing field and get the value of that backing field. So that's the implementation of get set under the hood. Nothing special. So what happens if properties private field is secretly created like name get? Is there no way to access the private field that way? Yes, there is no way to access it that another way. If you want to call a property, it's the same as calling a field, and that's the beauty of it. So second. All right. And last one. So we create a person. Tom Thompson, let's say. And if we want to just print its name, we say person dot full name or person dot name. Like, we don't need to call this as a method. It is a method, but we call it as if it was a field. That's the benefit of properties. It's very easy to use. And normally, you wouldn't even see any getter and setter methods in C# manually done. That is taught from the very beginning, but I just wanted to introduce the difference so that you can compare how it differs compared to properties. And properties are really nice, convenient way. They don't exist in most languages though. I think C++ have properties, but other languages don't really have them. And this sucks a lot for those languages because it makes code much more readable and there's less boilerplate code like this. So, yes, there's a lot of code snippets in this Um, yes, you can. Except that that index can be any type. It doesn't have to be an integer. It's just a different syntax for calling something that belongs to an object. You call it through those broken brackets, and it can be anything, really. Any key, any quote-unquote index. Yes. All right. Save, done. Kahoot time. Oh, what the hell? Oh, no, no, no. Okay, hide it. Put the sound a bit down. Okay. So the code for the room, for the site. Can you implicitly convert an int to Enum? So you have full bar A, where bar is Enum. Can you then do like full int? No, you cannot. You need to cast it. So let's say we have gender. And if I call full static, if I call full with gender, you see it doesn't convert. So I just need to cast it. All right, let's start. I should really remove those default images. Horrible. So what's the difference between a property and a field? Oh no, the time. It's 20 seconds. Crap. Okay, I will abort the game. Abort the game. The time is messed up. We cannot play with 20 seconds. Sorry about that. Kahoot. Give me 2 minutes to fix the time. Sorry, really sorry about that. Okay. Okay. Now it's good. Play host. Okay. Classic. Sorry. Two more, one more. In the meanwhile, I'll link the slides. Okay, we'll start. What's the difference between a property and a field? So they're not the same. They're called exactly the same from the outside, but they're completely two different things semantically. One is a data, and the other one is a method. So it's different. Is it true that there is no reason to use getter and setter methods over property in C#? And the answer is yeah, it's really true. Only languages that don't support properties will use getter and setter methods, but they are not the way to go in C#. Enum is, what is enum? This is a very similar answer to this one, but a class with constants is literally a static class with const members. But this is the more accurate answer, though this is a close answer also, so it's not too bad if you chose that one, but this is the right answer. So does enum indexing start at 0? Yes, it does. Well done. Can enum indexing be overridden? Yes, it can. Property can have mixed access modifiers for get and set. Is it true or false? Yes, it can. Next. Is it true that in C# you should prefer list over array? And the answer is indeed, you should prefer a list over array. Array is limited. Array arrays faster, but in most cases you don't care about that performance. In most cases your collection changes, and if you re-implement array to scale every time, you will probably do it wrong. Because a list is not just some stupid implementation for scalable, resizable collection. It's really well thought, and there are many optimizations done for it. So if you what you guys did at homework is less performant than what you would do with list. So if the rule is this, if collection size changes, you should prefer to use a list and not array. And therefore, there's only a few cases where array suits in C#, and that is when you know the collection size, and you know the collection size when you have some predefined values for a collection elements, then array suits better. But list is the winner. And the answer is not always true, that's true, and therefore it was formulated as prefer list over array. You should prefer it because in most cases it collection changes. Yeah. I remember the other day I had a talk with my colleague, and he's been programming for 6 years in C#.NET, and he said he doesn't remember the last time he used an array. When programming, we don't really care about it unless it matters. It's micro-tuning performance. You don't want to re-implement those addition and removal of elements all over again for array. And for list, it's just given to you out of the box, so why not use it? And in all your homeworks, all the collections you had were with some operations that need to modify the size of a collection. So array is just not suitable there anymore, and list is preferable. So from your experience, you should already know that list over array is a more common case. A list under the hood is an array, but it's done smarter. For example, if you have a list of 5 elements, and if you add another element to a list, it won't increase the size of a list by 1. It will increase the size of a list double. So list usually doubles in size. That is the first optimization that is done for list. So if I have an empty list and I add a single element, it will create an array of 1 element. If I add another element, it will be 2 elements, so it will create an array of 2 elements. But if I add a third element, it will double the size, so it will be a list of 4 elements. So by adding the 4th element, it will not create a new list, a new array. Now, if I add 5th element, it will double in size, so it will be 8 elements. 4 filled and 4 empty. So that's the pattern for lists. I'm not sure if that's the chosen implementation, but I know that this is a common optimization for sizing, for changing the size of a list. So Michal Fox, number 1. What is the main benefit of a list over array? Yes, you can change the size of a list. You can add or remove elements from it. That's the main benefit, and that's why it's preferable, because that's the most common case. Stuff changes. The below code was called. Which of the following is false? And capacity there just shows optimization. Under the hood, the list is an array. So it creates an array with 5 slots. But those 5 slots doesn't mean that it must have exactly 5 elements. It just means that it will, when it scales, the sequence won't be 1, 2, 4, 8, but it will be 5, 10, 20, and so on. It will scale differently, starting from 5 elements. So it doesn't mean it cannot have more. It just means it will start from 5. So it doesn't mean it will be exactly 5. And therefore, that is false. And the winners. Aurora third, Aurora second, and Mihail first. Well done. You're welcome. The homework is quite simple. Oops. So you will need to take code from chapter 2, homework 2, and refactor that code to be using lists and properties instead of getter, method, methods, and arrays. Yeah, that's pretty much it. I think I can come up with an extra challenge on the spot. So extra challenge would be use Enum and indexer to simplify equipping no, that won't do. Yeah, that's all. Enums cannot inherit. Actually, I never tried, but I think they cannot inherit. Wouldn't make sense. What does it say? Oh, they can, but it's different. You see, I cannot do this, but I can say that it's not an int, but it's a byte or something like that. Like, I can specify the type that the enum is, but I didn't know that this was possible. So it's really weird. Okay. It's really weird, but it's cool. Royaloff, yes, there will be a branch for chapter 3 homework 1. That's where you'll be making your PR. I think the branch itself will just be the same as a clone of branch of homework 2. Yes, enums are in by default. Well, I mean, they're not ins by default. What am I saying? They're just numbers, whole numbers, that's all. And I guess if you specify like this, you just constrain it to be always no more than 255, that's all. Maybe, actually, when you think about it, where was that gender? Let's play around with this. So something. Yeah, it doesn't work. Okay. Probably this means that I constrained it not to be no bigger than 32-bit integer. If I say byte, that will mean that it cannot be, for example, 300, you see. But if I say int, that means it can be this. And if I don't say anything, and as I say int max, it still works. So it's an int by default. No, it wouldn't make sense if they were bytes. There is a flags enum as well for permissions, which goes over that. But the use of it is completely different, but I don't want to get into that. It's a completely different thing. But there is a use case for bigger enums than that. All right, so that's it for this lesson. So if you have a book and you have different genres of a book, would you say Enum is in use? Definitely yes. So for gender, genres, types, basically labels that don't really have behavior and are just, different data, but that belongs to a specific set, Enum is the way to go to use. So by suggesting this, you definitely are on the right track, that you understood enums. So yeah, definitely yes. Yes, Royaloff, you can clone that one and just start working on it. I think the only thing is that you will merge the different branch, that you will make a PR for a different branch. That's the only difference. And it will be ready tomorrow. So that's it for this lesson. Thank you everyone for your attention, and see you on Saturday. Bye bye.